I'm Anil Kumar, and here is a thinking question for you. The question here is determine the area of this shape. So we are given a shape like this where diameter is 8 centimeters. So diameter of this circle is 8 centimeters. And we need to find area of the portion shown. 5 centimeter is this chord here. So if I complete this circle kind of like this, right, let me just complete it, then you need to find area of this portion, right? That is what is the question for you. So I'd like you to pause the video, solve this test question, and then look into my suggestion. Now in such cases, what we should do is we should first find what is the area of the sector, and then we could take away area of this triangle. Let me just complete this from the whole area of the sector. So if I take away area of the triangle from the sector, then I know area of this segment, right? And then we can find area of the shaded portion. So this could be multiple step question for you, correct? So let's begin by writing down what is the area of the circle first, right? So we say area of circle, let's say this is my circle, is pi r square. We know pi r square. Pi you can take as 3.14. Radius, since diameter is 8 centimeters, we know radius is 4 centimeters. So 4 square, correct? Let's calculate this value. So we have 3.14 times 4 square, which is 50.24. 50.24 units are centimeter square. So in the first step, we found the area of full circle, right? Now, as you can understand, we know this length is half of 8, so which is 4 for us. If we know one side length, and let me drop a perpendicular on this chord from the center, right? So if I drop a perpendicular here, then in that case, what we can do is, we know this will bisect it, correct? So it will bisect it since we know these are the radius. So the length of this, or the height of this triangle, is 2.5. So let me redraw this particular half triangle here for you, right? So what I'm doing here is I'm drawing half triangle slightly bigger. So let me just make a bigger triangle here. Let's say we scaled it up, right? So in this particular triangle, what we have is, this is the radius 4 for us, and that is half of this 2.5, correct? And this angle is half of the whole angle. So let's say this angle is theta by 2, half of the angle, right? So if theta is the whole angle, so we can find this angle theta by 2 by using sine ratio, since we know this is perpendicular, correct? So we say sine theta by 2 is opposite over hypotenuse, which is 2.5 over 4, and from here we know what theta by 2 is. So if theta by 2 is equal to sine inverse of 2.5 divided by 4. Now all this should be in radians, right? So first is you convert your mode to radians, which in our case will be 4. Now it is in radians. And now we will do sine inverse. So we'll do sine inverse of 2.5 divided by 4, bracket close, equals to 0.67. Let me write down 0.67513. It's good to take at least 4 decimal places for accuracy, right? So we get theta by 2 as 0.67513. So times 2 will give us the angle. So angle theta for us is 2 times that. Let me write 2 times 0.67513, which is 1.350. Let me write 1.35. So 1.35 radians, right? So that is the angle at the center of this particular, you can say now, segment, correct? Now to find the area of this segment, we should first find area of the sector and then take away area of the triangle, correct? So let me write down the area of the triangle also. So we can find height of this triangle, correct? So that means this side we can find now. So what is this side equals to? Since we know the angle, correct, angle is 0.67513, this half angle, from here we can find the side length. So we say cos of theta by 2 is equal to, let's call this as height h, right? So h over 4. So that means height h equals to 4 times cos of theta is 0.67513, correct? So let's find this height. So it is 4 times cos of 0.67513, right? Bracket close equal to, we get 3.122. Well, you could also do 4 square minus 2.5 square root. So we'll do that also. Square root of 4 square, that's easier actually, minus 2.5 square, right, equals to. So you get the same answer, 3.122, right? So either way, you get the height. Once we know the height, we can say area of triangle. So area of triangle is equals to half. Base of this triangle is 5, right? Let me write formula first. Base times height. So which is half. Base is 5 for us. Let's write it in brackets. And height we just calculated 3.122, right? So using these values, so 3.122 is already there, times 5 divided by 2 equals to, so we get a value 7.8. Let's use 7.8 as area of the triangle in centimeters square, correct? Now let's find area of the sector, right? The whole sector. So we get area of the sector. Now it is area of the full circle, which is pi r square. Pi times r is 4, so let's say pi r square. Full circle times the ratio of angle to 2 pi. Now the angle theta which we found was 1.35 radians. So we'll multiply by 1.35 radians and divide by 2 pi, correct? 2 times. So let's calculate this. So once you simplify, pi and pi cancels out, so it becomes slightly easier. Let's use this calculation. So we have 4 square times 1.35 divided by 2, 10.8. So area of the sector is 10.8, correct? So that is the whole thing. Now let's take away the area of the segment. So area of the segment is how much? Area of segment is area of full circle. So area of circle minus area of, area of sector minus area of triangle, correct? So area of sector is 10.8 minus area of triangle, which is 7.8, so we get a value of 3. So area of the segment is 3 centimeters square. Perfect. So what is the area of the total shape now? So area of shape is equals to area of circle, full circle, minus area of segment. Is it okay? Area of circle we just found pi r square, which is 50.24 minus area of segment, which we calculated as 3 units, correct? So let's take it. So 50.24 minus 3 is equals to 47.24 centimeters square, correct? So that is how you could find area of the shape given to you. So in this particular example, we used a lot of learnings from the previous video. So what we learned here was, first, in such a case, figure out a triangle. So that find the area of that triangle, right? To find the area of the triangle, you need the height. So when you drop a perpendicular on the chord from the center, you can find the height using Pythagorean theorem. That is better. Find the height. Then, using primary trigonometric ratios, find the angle of whatever is made at the center. Knowing the angle, you know area of the sector, correct? So taking away area of triangle from the sector, you know area of the segment, which you can take away from the area of the circle to find area of the dimension given to you. And I hope this helps you to bring everything together. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.